Welcome you all in lecture number 19 of Engineering Mathematics 1 MTL 1025. Okay. In this lecture, we will going to discuss Cauchy mean value theorem. Cauchy mean value theorem. Okay. And one example of Cauchy mean value theorem. And one application of maxima minima. One application of maxima and minima. Okay. So let us start with the Cauchy mean value theorem. But before going to Cauchy mean value theorem, before our mid-semester examination, we already studied about the Rolle's mean value theorem and Lagrange's mean value theorem. Okay. What Rolle's mean value theorem states? If a function fx is continuous in closed interval AB, and second condition, fx is differentiable in open interval AB, and third, value of the function at the endpoints are equal, then results of Rolle's mean value theorem states that there exists C belongs to open interval AB such that derivative of f at the point C is equal to 0. There exists one C, at least one C. If any f satisfy these three conditions, then there exists at least one C in AB such that f prime C is equal to 0. This is the statement of Rolle's mean value theorem. Okay. Using this Rolle's mean value theorem, we already studied the Lagrange's mean value theorem, and now come to the Cauchy mean value theorem. In Cauchy mean value theorem, we will assume two functions. We will consider two functions. Okay. Now see, if fx and gx be two continuous functions in closed interval AB, right? Both functions are continuous in closed interval AB. Both functions are differentiable in open interval AB. Okay. Then f of b minus f of a divided by gb minus ga is equal to f prime c divided by g prime c, provided that one condition is given: g prime x does not equal to 0 for any value of x in AB. Okay. In such condition, fb minus fa is equal to fb minus fa divided by gb minus ga is equal to f prime c divided by g prime c. Okay. So let us the proof of Cauchy mean value theorem. We will prove Cauchy mean value theorem on the basis of Rolle's mean value theorem. Okay. Let us consider a new function on the basis of fx and gx. Let us define phi x. What is phi x? Fx minus fb minus fa divided by gb minus ga, right, into gx. Okay. What is phi x? Phi x is continuous. Yes, phi x is continuous. Why phi x is continuous? Phi x is continuous since the difference of two functions is continuous, right, by algebra of continuity. If fx is continuous and gx is continuous, then their difference is continuous. Okay. So this fx is continuous, this term is constant term, and gx is continuous. Okay. So difference of two continuous function is continuous by algebra of continuity. And second condition is that f prime x and g prime x exist in AB. It is given in the statement, second condition of Cauchy mean value theorem, right? Also, we can show that phi of b is equal to phi of a. Now see, what is phi of a? Phi of a is equal to f of a minus FP minus FA divided by GB minus GA multiplied by GA. Okay, and phi B is equal to FP minus FA divided by GB minus GA multiplied by GB. You can easily verify that this phi A is equal to phi B. Okay, so this phi function, this phi x defined in this way, satisfy all the conditions of Rolle's theorem. Satisfy all the conditions of Rolle's theorem, right? Then apply the result. Then there exists C such that phi prime C is equal to 0. Okay. This phi x satisfy all the conditions of Rolle's theorem. Then the result says that then there exists C in open interval AB such that phi prime C is equal to 0. This is phi prime C. Phi prime C is equal to 0. If phi prime C is equal to 0, what is phi prime C? Phi prime C equal to 0 implies that F prime C minus Fp minus Fa divided by Gb minus Ga into G prime C, and this implies that Fp minus Fa divided by Gb minus Ga is equal to F prime C divided by G prime C. Okay, this thing. So this is the statement of this is the result of Cauchy mean value theorem. Okay, see one example. Verify Cauchy mean value theorem for the two simple function e to the power x and e to the power minus x in interval AB. Okay, see, exponential x and exponential minus x both are continuous function. Okay, no problem. This is continuous every real line, every point of the real line. Okay, then this ex and e to the power minus x is continuous in AB. Okay, this is differentiable in open interval AB. Okay, this is continuous in closed interval AB and differentiable in open interval AB. Yes, then it satisfies fx equal to ex and gx equal to e to the power minus x. These two satisfy the conditions of Cauchy mean value theorem. So the result of Cauchy mean value theorem says that Fp minus Fa, it means Eb minus Ea divided by Gb minus Ga, means what is G? G is equal to e to the power minus x. E to the power minus b minus e to the power a is equal to F prime. What is F prime? F prime x is equal to Ex, that is Ec. And what is G prime? G prime is minus e to the power minus c. Okay, right? So after solving this, we got 1 by c is equal to 1 by 2a plus b. Okay, this is the result of Cauchy mean value theorem. Now come to the one important question, say one application of maxima and minima. Okay, now consider one example of maxima minima. Say a rectangular box, suppose this is the box. Okay, this is here H, this one is B. Okay, so rectangular box open at the top, this part is open, this part is open. So the surface area is given by LB, fill from the different color, this LB plus 2 times LH plus 2 times BH. Okay, 2 times LH, 2 times BH. Okay, so this portion and just opposite of this portion, this is LH, LH plus LH, 2LH, and this one is BH, this one is BH and BH. Okay, So 2BH, 2BH, 2LH plus LV. Okay. This one is 2LH. Sorry, this is not LV. This is LH. Okay. Now see, volume is given 32 cc. Okay. The volume is given 32 cc. Okay. Find the dimension of the box requiring the least material for its construction. Okay. So what is the volume? LBH. LBH is equal to 32. Now we know that maxima and minima are two variable. So it contains the three variable: length, width and height. So now we have to convert from this volume relation this three variable equation into two variable. Then B is equal to any one variable you can replace whatever whatever you want, either B or H or L. Then B is equal to 32 by LH. What is B? B is equal to 32 by LH. Okay. Then this S is equal to, putting this value of V in S. So this is 2LH. Okay. 2BH. In place of B, put 32 by LH. Okay. In place of B, putting 32 by LH. So 32 into 2 is 64. H and H is cancelled out, divided by L. Okay. And in place of this B, 32 by LH. So this is 32 by H. This one is ES in two variable. What is this? In two variable. So apply our previous concept of maximum minimum for two variable. Okay. Now ds by dl, sorry, dou s by dou l and dou s by dou h is equal to 0. Right? Give the critical point. Now see, dou s by dou l is equal to this thing and dou s by dou h is equal to this thing. So dou s by dou l is equal to 0 and dou s by dou h is equal to 0. This one for find out the critical point. Okay, for the critical point. If dou s by dou l is equal to 0, then this is 2h minus 64 by l square is equal to 0. This implies that h is equal to 32 by l square. Okay, and for dou s by dou h is equal to 0, this is 2l minus 32 by h square is equal to 0. So l is equal to 16 by h square. Okay. Now this solving equation 4. Equation 4 means, okay, putting L here, we got H. What is H? H is equal to 2. Okay. So this H is equal to 32 by L square. What is L square? 16 into 16 divided by H to the power 4. That is H is equal to 32 H to the power 4 is equal to 16 into 16. Right? This 32, this is equal to 2, this is equal to 8. So H cube is equal to 8. So H is equal to 2. This H is equal to 2. Okay. Okay. Now see, if H is equal to 2, then what is L? L is equal to 4. Right? Then what is B? Since L into B into H is equal to 32. So this 4 into 2 into X is equal to 32. So the B is equal 4 into 2 into B is equal to 32. So B is equal to 4. Okay. Now come to the second derivative. Dou 2s by dou L2. What is second derivative of this term? Second derivative of this term is minus, sorry, it is already positive. 128, since this is minus already, so it is positive. 128 by L cube. What is L? L is equal to 4. Okay. L is equal to 4. So dou 2s by dou L2 is equal to 2. Dou 2s by dou L dou H is equal to 2. And dou 2s by dou H2 is equal to 8. Dou 2s by dou H2 is equal to 64 by h cube. What is this 64 by h? What is h? h is 2. 2 cube is equal to 8. Now this is equal to 8. So dou 2s by dou h2 is 8. Now what is r? This one is r. This is t. So r into t, 2 into 8 minus s square. What is s? s is equal to 2. So 2 into 8 minus 2 square, this is equal to 12. 12 is greater than 0. Okay. Now see, s is minimum. Yes, s is minimum. If s is minimum, for which value of L, B and H? Since RT minus CS square is greater than 0, and what is R? R is equal to dou 2s by dou L2, that is 2. 2 is greater than 0. So this L4H2B4, this is the minimum condition. So this is the minimum. Okay, this much material required, right? Okay, thank you.